Hello. So for you to perform addition of a matrix, you must first check the matrices involved, whether they have the same dimension. If they have the same dimension, addition is possible. If they don't have the same dimension, addition is not possible. The same also for subtraction. So for subtraction, if they have the same dimension, subtraction will be possible. If they don't have the same dimension, subtraction won't be possible. So let's take question. So for this question, we have to find A plus B. Let's first identify the dimension of A. So for A, its dimension will be m by n. How many rows? One, two. How many columns? One, two, three. For B, let's check. How many rows does B have? One, two, three. How many columns? One, two. So two columns. So since the dimension of A and the dimension of B is not the same, two by three is not the same as three by two. Hence, addition is not possible. So addition is not possible because dimension of A is not equal to dimension of B. So let's move on to II. We have to find the sum of P and Q. So we for straight I can identify that the dimension of P and Q is the same. It will be three by three because they have P has three rows, one, two, three, three columns, one, two, three. Q has three rows, one, two, three, three columns, one, two, three. Hence, addition is possible. So how do we perform this addition? So you take let's say for row one of P, you take the first element and add it to its corresponding element of Q. So one will be added to two. So when you take two will be added to one. When you take three will be added to zero. So it will be of this way. P plus Q will be we have one, two, three, four, five, six, one, zero, negative one for P and Q. Q will be that's solving II. Q will be two, one, zero, three, negative one, four, one, zero, seven. This is how the addition will be. You take one, add it to its corresponding number. Take two, add it to its corresponding number. You take three, add it to its corresponding number. You move on to the next row. You take four, add it to its corresponding number. You take five, add it to its corresponding number. You take six, add it to its corresponding number. You move on to the next row. You take one, add it to its corresponding number, which is one. You take zero, add it to its corresponding number, which is zero. You take negative one, then we add it to its corresponding number, which is seven. Now we evaluate this. So let's take this. 2 plus 1 will be 3. 2 plus 1 will also be 3. 3 plus 0 will be 3. 4 plus 3 will be 7. 5 minus 1 will be 4. 6 plus 4 will be 10. 1 plus 2 will be 2. 0 plus 0 will be 0. Negative 1 plus 7 will be 6. So we have found B plus Q. I hope you can find A transpose plus B. Go ahead and see whether you can find A transpose plus B. So let's move on to the third question where we find A transpose plus B. So we already have A, we have B, but we don't have A transpose. So let's first find A transpose. So we are solving this. So for A transpose, how do we find transpose? So transpose, you take the rows and express them as a column. So for A, let's take the first row, 2, 3, 4. Express it as a column, 2, 3, 4. For the second row, 1, 5, 2. Express it as a column, 1, 5, 2. We have found the transpose of A. So let's compare A transpose with B. And let's see whether they have the same dimension. Yeah, they have the same dimension, hence addition is possible. So what's the dimension of A transpose? It is 3 by 2. Look at 1, 2, 3, 3 rows, 1, 2, 2 columns, which is 3 by 2. So you could write M by N, then you can write 3 by 2. So let's find the dimension of B. Dimension of B will also be 3, 3 by 2. We got 1, 2, 3, 3 rows, 1, 2, 2 columns. So addition is possible. Hence, let's find A transpose plus B. So A transpose is this. Then we have B. B will be plus, we have 1, 0, 1. We have negative 1, 2, 3. Now let's sum them. We take 2, add it to its corresponding number. We take 1, add it to its corresponding number. So it will become 2 plus 1, 1 plus minus 1. This one will become 3 plus 0, 5 plus 2. This one will become 4 plus 1, 2 plus 3. Now let's simplify it. 2 plus 1 will be 3. 1 minus 1 will be 0. 3 plus 0 will be 3. 5 plus 2 will be 7. 4 plus 1 will be 5. 3 plus 2 plus 3 will be 5. Hence, this is the result for A transpose plus B. Let's go ahead to find the subtraction of the matrix. So to find the subtraction of the matrix, you have to make sure that they have the same dimension, which means if matrix A, for instance, is 2 by 2, matrix B should also be 2 by 2 in order for subtraction to be possible. So let's solve a question to understand subtraction of the matrix. So we have this question where we are to find Q minus P. First, let's check whether Q and P has the same dimension. So Q's dimension will be 3 by 3. Since it has 3 rows, one, 2, 3, and 3 columns, one, 2, 3. Let's also check for P. P will also be 3 by 3 because it has 3 rows, 3 columns, one, 2, 3, one, 2, 3. Yeah. Hence, subtraction is possible. So the question says Q minus P. This time we are taking Q first, then minus P. So let's write Q. Q has 210, 210, 3 negative 14, 3 negative 14, 107, 107. P. P has 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6, 1, 0, negative 1, 1, 0, negative 1. So subtraction is like addition. We take the first row, and for each element, we will take, let's say for this row 1, we take the first element and subtract its corresponding element from it. We move on to the second element, we subtract its corresponding element from it. We move on to the third element, we subtract its corresponding element from it. The same goes to the next row 2. We do same for row 2, we do same for row 3. So let's go ahead. So row 1, we have 2. 2 minus its corresponding element, which is 1. We have 1. 1 minus its corresponding element, 2. We have 0. It will be 0 minus 3. We have 3 in the second row. 3 minus its corresponding element, 4. So it will be 3 minus 4. We have negative 1. Negative 1 minus its corresponding element being 5. We have 4. 4 minus its corresponding element being 6. We have 1. 1 minus its corresponding element being 1. We have 0. 0 minus its corresponding element being 0. Then we have 7. 7 minus its corresponding element being negative 1. Okay. So we go ahead and simplify. 2 minus 1 will be 1. 1 minus 2 will be negative 1. 0 minus 3 will be negative 3. 3 minus 4 will be negative 1. Negative 1 minus negative 1 will be negative 6. 4 minus negative 6 will be negative 2. 1 minus 1 will be 0. 0 minus 0 will be 0. 7 minus negative 1. Negative 1 and negative 1 will become positive. So it will be 7 plus 1. 7 plus 1 is 8. So this is the result for Q minus P. Let's move on to finding B minus A transpose. So we have to find B minus A transpose. But first, let's find A transpose. So for A transpose, we take A, we express each row as a column. So let's take the first row. It has 2, 3, 4. We express this as a column 2, 3, 4. Second row 1, 5, 2. To become 1, 5, 2. We have found A transpose. Now we have to find B minus A transpose. So I what is B? This is B. B has 1, negative 1, 0, 2, 1, 3, minus A transpose. This is A transpose. So it has 2, 1, 3, 5, 4, 2. Now let's perform subtraction. So we'll take the first row and the first element. The first element, we subtract its corresponding element from it. The second element, we subtract its corresponding element from it. So it will be 1 minus 2, negative 1 minus 1. Move on to the next row, 0 minus 3, 2 minus 5. We move on to the third row, 1 minus 4, 3 minus 2. Then we go ahead and simplify. So 1 minus 2 will give you what? Minus 1. 1 minus 1 will give you minus 2. 0 minus 3 will give us minus 3. 2 minus 5 will give us minus 3. 1 minus 4 will give us minus 3. 3 minus 2 will give us 1. So this is the result for B minus A transpose.